So in section 3.3, just call it truth tables for negation, conjunction, and disjunction. We're going to start to get down to what does a statement mean? What is its actual true-false value? So when we do this, we're going to assign two truth values. We're going to use capital T for true. And similarly, we will use capital F for false. And remember, a statement can only either be true or false, but not both. So when we have a statement, it has to evaluate to one of these things. Okay. As we define what we mean by a statement, we're actually going to be making little tables that encapsulate that value, that information. So for example, here's the truth table for conjunction. Given these two inputs, it shows us, if you have true first and false second, this gives you an output of false. Okay, so that's going to be a big key to what we learned in this section. Also, if we know P is true and Q is true, we can find the truth value of it is not true that not P or Q. Okay, we'll do those kinds of problems in this section. And the way that works is basically we'll substitute in, we know P is true, we know Q is true. Then I'll look up using negation what this is. The negation of true is false. Then I'll go to my truth table for this symbol. This symbol says if you have a false first and a true second, you get a true. And then finally we take the negation of that, and this is false. Okay, so we'll be doing problems like this in this section. And then also, we'll do things where we make truth tables. If I wanted to make the truth table for it is not true that not P or Q, basically what I'm doing is I'm going to create something where I have all the possible inputs for P and Q. And then I'm going to have across the columns here my steps. And my goal is to make it so that this table will show me, given any two inputs, P and Q, what the value for this whole thing is. So for example, if P is true and Q is false, this statement will evaluate to true. If they're both true, which we did up above, this statement evaluates to false. So this table basically encapsulates four problems like this. It just does the work going horizontally instead of vertically. That's what we're going to cover here in section 3.3 and frankly in 3.4 just with some more connectives.